Hey folks, as so often happens, one examination of a subject allows the collective of observers to demonstrate their force. Within just minutes of yesterday's video, which is now a part 1 to this part 2, another video was sent to me describing something I totally forgot to include in yesterday's video, but which complements it nicely, and luckily I can still post videos here a day later, so problem is solvicus in progress. Now, to properly place this oversight of mine into context, let's quickly drive through the major points yesterday, then show what I forgot, and then frame the bigger picture in light of the evidence. The Janibekov effect does not really resemble the tennis racket theorem, intermediate axis theorem, and in either case is not what we believe to be the trigger of the crustal disruption. But we also took the time to do the mental exercise anyway of applying it there, and showed why even though Earth's bulge makes Earth non-spherical, and even though our orbital distance from the Sun changes by the year, there are even greater stress variations on the planet, like our heliographic latitude track, which goes 7 degrees south and 7 degrees north of the solar equator. As equinox and solstice and these heliographic moments come and go, the stress of our orbital motion and rotation relative to the Sun and Moon are constantly changing even now, making for slight dings in different directions all year against different magmatic and oceanic conditions. And over longer periods, the variations are even more dramatic: obliquity, eccentricity, axial and apsidal precession, and we even went deep into the large-scale subterranean structure that really disallows the fluid-filled sphere concept from applying to a geodynamic analysis. Now this is where our theory meets the Janibekov effect and intermediate axis concepts, showing where they may indeed be applicable to an Earth flip scenario. We will come back to our major points and our hypothesis at the end, but first, as I mentioned, the reason for this video is that I forgot something. A video posted 2 years ago by Sean here is epic. I hope he will be cool with us sharing his work, and I also encourage you to click the link below the video, like his video, and thank him in advance for allowing its use. He used a very popular, well-vetted, and in fact professionally produced physics model program made for the purpose of the public. He put Janibekov physics into an Earth model but used the gravity models instead of the spherical model. The gravity of Earth does not exactly follow the sea level or the mountains, and it includes ice and other aspects of the very non-homogeneous Earth. And while the gravity amplitude and time are both exaggerated in this model for the purposes of making a short explanatory video that has effects you can easily see, the physics does say that when you don't oversimplify the Earth into a liquid-filled sphere, you get the flip and stability periods between. Now remember, this model uses just the gravity model of Earth, doesn't take into account the orbital or other dynamics we mentioned earlier, or the internal structure of the Earth disrupting the model from that perspective, although I do suspect that those large structures beneath our feet indeed are part of the gravitational variability of the planet. Again, this video was made 2 years ago. Let's show him some much overdue love and recognize that this just puts one more inch of doubt into the mind at ease message from Veritasium. Now back to the bigger picture, and because we add this to the other mechanistic actors we discussed, the major solar blast taking on the mantle, and perhaps even the core. One of the likely reasons that geomagnetic storms can produce the rotation glitches of Earth is their touching of the low velocity zone already, which is highly likely with the bigger blasts like the Carrington event, and certainly the biggest ones of all. With solar storms and core geomagnetic jerks being the only two known disruptors of rotation for those length of day glitches, what happens when you get them both together and at great magnitude? Mantle viscosity and thermoelectric disruptions unlock the crust at the low velocity zone. The mantle heaves, the large structure could break down, the plates collide, they endure vertical motion changes, and on the larger scales, the ice and mountain weight redistributions will pull heavier regions towards the equator for that final rearrangement. So again, that scenario does not require the Janibekov effect, but today we showed one more reason why you can't take it off the list of potential actors. In my opinion, the jigsaw crustal rearrangement seems more viable and less likely to kill the entire planet compared to the Earth literally flipping over. But like I said, there's too much evidence from all sides and inside and now models to write it off entirely. Eyes open, no fear. Be safe, everyone.